Hi guys, I want us to start some CFD analysis using ANSYS. And in my first example, I'm going to solve laminar flow based problem spec. Consider a fluid flowing through a circular pipe of constant radius. We have a constant radius here of 0.1 m and a length of 3 meters. And we have a velocity at the inlet that is 1 meter per second. Density is this value, viscosity this value, and the Reynolds number this value. At the atmosphere is pressure is 1 atmosphere. We're going to solve this using ANSYS Fluent. We're going to generate velocity vectors, velocity magnitude contours, pressure and velocity profile at the outlet. We're going to determine the outlet velocity. Okay, let's see how you can solve this problem spec. First thing I need is to define my geometry. I'm going to use 3 meter. I'm going to use a 2D analysis, that is 2 meter versus 3 meter versus 0.2 meter. I'm going to assume the flow is in 2D, not 3D, such that the effect of the z-axis, distance perpendicular to the screen, is constant. Therefore, the effect of parameters perpendicular to the screen is the same. Therefore, I'm going to start by geometry. Then we are going to use Fluent. Let's first of all define geometry. This is geometry here. This geometry, just drag it and right click geometry. You open SpaceClaim. Let's now model the 2D profile. I need units to be in meters. You go to File, SpaceClaim, Options, then select units to be in meters, then OK. I'm going to use X and Y because we have said the cross section along the z-axis, the parameters remain the same. Therefore, I want to sketch on this X and Y. Therefore, sketch mode onto XY. You hover like that, XY. I want to view normal to this first one here. Select rectangle, snip at the center, then press 3, then tab, then 0.1, enter twice. Then we can say add sketch editing. You can now zoom, extend. This now is our surface. As you can see, it is 3 meter by 0.1. If you want to measure, you can measure from this point to this point. You have to press Ctrl if you want to measure. You can see 3 meter. Minimum distance is 3 meter. Then this one is a meter. As you can see on the here, this one is a surface. We are using a 2D for now. I can rename to 2D surface. Therefore, this will be our entry and our exit. This is our center line. I'm going to assume that if I draw a line here at the center like that, the parameters on this side is the same as parameters on this side. Therefore, because we are going to get a velocity profile like this, Therefore, you see like the parameters on the top side is the same as bottom side. The reason why I want to simplify my model, instead of modeling a complete geometry, I can model just half the section. Okay, then go back to the workbench. The geometry, I'm using Fluent. You can drag this geometry here. Let's now mesh. We need to mesh our geometry now. You can say edit. Now this is the mesh environment. I need to view this normal to the z-axis. Just select z-axis. This is the one is the z-axis, like that. Then the first thing we need to do is to generate a default mesh. If you say generate mesh, you can see this mesh is very coarse. Therefore, we need now to fine tune this mesh a little bit. I'm going to use sizing. Let me use edge sizing. You select those two edges here. I want these edges to have, instead of element size, because this one is a very simple model, I can say number of divisions and use 10. Same case applies to the bottom and top and bottom edge. You can duplicate and use these two edges here. If you update, let's see what happens. You can see now how it is. We need to define number of divisions on edge sizing 2. Let's use 100 and update the mesh. You can see now the mesh is a little bit fine, but it is not uniform. You can see at the start, because we said generate 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 number of divisions. This one is 100, and the mesh is not uniform. I want this mesh to be uniform across the full surface. For that I can do what we call phase meshing. It enables generation of a free or mapped mesh on a selected face. Therefore, if you select this face, if you now generate update, you'll see now the mesh becomes uniform throughout the face. You can see the mesh is continuous, doesn't break. But if you zoom in a little bit, you can see on this edge, the element size is uniform, but varies across this edge. For example, this one is longer, this is shorter. How can you fix this? You go back to the edge sizing. Instead of using soft enables the mesh size to change. I use hand again. If you update, you can see now the mesh size is the same, because we want to have exactly same element size that are 100. The reason why we are using hard, not soft. Okay, next we need to define our boundaries. This one is inlet, this one is inlet, this is outlet. We have a center line. Remember, we have a center line here, and we have this wall. That's wall. Let's define those boundaries. I go back to model. I need now to select this edge, right click. You say create named selection, call it inlet. Same case applies to outlet. You can see we have inlet here and we have outlet. This one we said is center line. This one is center line. This one is a pipe wall. Let me use underscore pipe wall. Yeah, we have inlet, outlet, center line, and pipe wall. Then this surface is my flow domain. This surface, we call it flow. This represents the liquid that is going to flow. Therefore, we give it a name as a flow domain, like that. We don't need to define the material. The flow analysis is not affected by properties of the material unless we want to go to deeper to understand boundary conditions. But for now, the simple model, we just need inlet, outlet, centerline, pipe wall, the flow domain. Now in my next video, we will now go into the software setup to see how you can set up now the parameters. Yeah, lastly, you need to right click this mesh and update so that everything is updated. Therefore, we'll be moving step by step. We have done geometry and mesh. Next, let's meet in setup. Thank you. See you in my next video.